Hello everyone. So today we're going to have the conversion of decimal to binary and binary to decimal number system. So before we proceed to proper conversion, first let us discuss what is the decimal number system. So this number system are represented with base 10. The way of denoting the decimal numbers with base 10 is also termed as a decimal notations. This number system widely used in computer applications. It is also called the base 10 number system, which consists of 10 digits such as 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In each digit in the decimal system has a position, and every digit is 10 times more significant than the previous digit. Suppose we have 25 in a decimal number, then 2 is 10 times more than 5. So we have a example of decimal number system or decimal numbers. So we have 12 base 10, 345 base 10, we have 119 base 10, and 200 base 10. So these are the example of a decimal number system. And also the decimal number system is commonly used in our daily lives. Next, we have the binary number system. So what is the binary number system? So this number system, according to digital electronics and mathematics, a binary number is defined as a number that is expressed in the binary system or base 2 from the root word bi, which means 2. So it describes numeric values by two separate symbols, 1 and 0. So there are only two figures or bit that you can see in a number or in a binary number system, which is 1 and 0 or 0 and 1. The base 2 system is the positional notation with 2 as a radix. So the binary number system is applied internally by almost all latest computers and computer-based devices because of its direct implementation in electronic circuits using logic gates. So the logic gates are the different gates in a digital electronics that uses a positive 5 volts and 0 volts. So which is applicable in using the binary number system, which is 0 is equals to 0 volts, 0 volt, and 1 for positive 5 volts in using logic gates. So every digit is referred to as a bit. So since in decimal number system, in every figure, we call it a digit. While in binary number system, in every figure, we call it a bit. So this is an example of a binary number system. We have here 101 base 2, 1011 base 2, 1110101 base 2. So this is an example of a binary number system. So each number system or each figure, we call it the bit. A group of 4 bits, we call it the nibble. And a group of 8 bits, we call it a byte. Again, a single a single number in the binary number system, we call it a bit. A group of 4 bits, we call it a nibble. And a group of 8 bits, we call it a byte. Next, let us proceed now to converting the decimal to binary number system. So, to convert a decimal number into an equivalent binary number, we have to divide the original number system by 2 until the quotient is 0 or until you have number 1 when no more division is possible. So the remainder so obtained is counted for the required number in the order of LSB, which is the least significant bit, to MSB, the most significant bit. And the most popular way to convert a decimal number into binary is the double-double method. It means you're going to divide the decimal number into 2 until you acquired the 0 answer, or the quotient is 0, or the remaining number is 1. So, the given decimal number is progressively divided by 2 and writing the remainder after each division when all the remainder is read in reverse order, or the LSB to MSB. Okay, so let us have the steps for decimal to binary conversion. First, you're going to divide the decimal number which is to be converted by 2, which is the base of the binary number. Next, we have the remainder, which is the obtained from step 1 is the least significant bit of the new binary number. Next, we have to divide the quotient, which is obtained from the step 2, and the remainder obtained from this is the second least significant bit of the binary number. Then, you're going to repeat the process until the quotient remains 0 or until you achieve the number 1. And then the last remainder obtained from the division is the most significant bit of the binary number. Hence, arrange the number from most significant bit to the least significant bit from bottom to top. Okay, let's have an example. So suppose we have 36 base 10. So we're going to convert 36 into binary number. So first, you're going to divide 36. So 36 divided by 2 is equals to 18. Since the quotient is 18, an exact number or exact quotient, so there is no remainder or remainder. The remainder is 0. So you're going to write number 0. So to represent the remainder. Next, the quotient in 36 divided by 2 will be divided into 2 again. And then 18 divided by 2 is equals to 9. And the remainder again is 0. Because 9 or the quotient 9 is exact number in or the answer in 18 divided by 2. Next, 9 divided by 2 is equals to 4, which is 4, we have a remainder of 1. So 9 divided by 2 is equals to 4, remainder 1. Now, in this answer, so you're going to divide again the quotient, the exact quotient 4 into 2 again. So there's no need for you to add the remainder. So it remains on the side of your quotient. And then 4 divided by 2 is equals to 2. So there is no again remainder. So the remainder is 0. Next, we have 2 divided by 2 is equals to 1. So again, 2 divided by 2 is 1. Remainder 0. And then when you have your quotient 1, you're going to stop the division by 2. And then the remaining one or the last one, you're going to write it on the most significant bit. So again, once you achieve the quotient 1, there's no need for you to divide it by 2. So you're going to write it in the most significant bit. So you're going to write it. So 36 is equal to, so you're going to write it from the most significant bit to the least significant bit. So we have 1, 0, 0, 1, 0, 0, base 2. So again, so 36 base 10 is equals to 1, 0, 0, 1, 0, 0, base 10. So do not read the binary numbers by or like a decimal number system, because it will confuse your numbers or your computations. So 100 base 2, do not say 100,100. It will be confusing in your number system. Okay, so let's have another example. 78 base 10, we're going to convert 78 base 10 into binary number system. So 78 divided by 2 is equals to 39. So there is no remainder. So remainder 0. And then the quotient, so 39 divided by 2, so equals 19, remainder 1. Next, we have 19 divided by 2 is equals to 9, remainder 1. And then 9 divided by 2 is equals to 4, remainder 1. And then 4 divided by 2 is equals to 2, remainder 0. And then 2 divided by 2 is equals to 1, remainder 0. And then since bring down 1, so there's no need for you to divide it by 2. So write the last one into the most significant bit. And then again, 78 base 10 is equals to, then write it from the most significant bit to the least significant bit. So 78 base 10 is equals to 1001110 base 2. So this is the process in converting decimal number into binary number. So remember, no, it is a technique that if you divide a even numbers, so there is no remainder. Once you divide an odd number, there is always a remainder 1. So when you divide again an even number into 2, there is no remainder. Once you divide an odd number into 2, there is always a remainder 1. Okay? So those are the process in converting decimal number system into binary number system. Okay? Next, we have the step for binary to decimal conversion. So this is converting binary numbers into decimal. So it is the vice versa of a decimal to binary. So step 1, you're going to write down the binary number and list the power of 2 from right to left. So this process is you're going to write the power of 2 from right to left. So this is also a what do you call that, the same in decimal number, which is we call it the place value. So in binary number system, there is also a place value. So in binary, let us have the 2 raised to 0, which is the 1. Then we have the 2 raised to 1, which is the 2. Then 2 raised to 2 is 4. So as you can see, every place value, it doubles the number. So first we have the 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and so on. So those are the place value of a binary number. So first step 1 is you're going to write it. Okay. Next, write the digits of the binary number below their corresponding powers of 2. So, so you're going to have or to write the binary number into its corresponding place value. So as you can see, so it is placed on the exact place value. So each bit has a place value in the binary. Next, connect the digits in the binary number with their corresponding powers of 2. So as you can see, we have 1 is correspond or its corresponding power of 2 is 128, 0 for 64, 0 for 32, 1 for 16, and 1 for 8, 0 for 4, 1 to 2, and 1 to 1. Next, we're going to write down the final value of each power of 2. So you're going to write. So you're going to write the place value of the value of each power of 2 to only or it to the bit of 1, or it has a bit of 1. So since 1 to 8 has a corresponding so 1 has corresponding power up to of 128, so you're going to have 128, and then 0 0, then 16, 8, 0, 2, and 1. So in this step, you're only there is also a step, no, that you're going to write only the power of 2 which has a 1 bit. Remember that. You're going to write only the value of power of 2 or corresponding power of 2 to a bit with 1. Okay, or 1 bit. Do not write the corresponding power of 2 in 0 bit. So, next step is you're going to add the final value. So, you're going to add 128 plus 16 plus 8 plus 2 and then plus 1. There's no need for you to write or add 0 because it is 0. No? So you only add the numbers that has a 1 bit. Remember that only has a 1 bit. So 128 plus 16 plus 8 plus 2 plus 1 is equals to 155. And then write the answer along with the base subscript. So 1001011 base 2 is equals to 155 base 10. Okay, so those are the process in converting binary into decimal number. Okay, so let's have an examples. Suppose we're going to convert 1001101 base 2 into decimal. First, you're going to write now the binary numbers. So 1 sorry, you're going to write the power of twos or the place value in the binary numbers. So we have 1, 2, 4, 8, 16, 32, 64, and 128. So these are the power of 2 or the place value in binary numbers. So I only write, no, I only write the 8 place value because we have here the 8 bits, or we have a group of 8 bits in our example. So now write the binary numbers below the place value. So we have 1 0 1 1 1 0 0 1. So we have the binary numbers below the place value or the power of twos. So then you're going to write only the place value that has a 1 bit. That has a 1 bit. So we have here 100. All right. So we have the place value of 128, and then there's no need for you to write the place value of a 0 bit. As I told you earlier, you're going only to write the 1 bit that has a 1 bit. So you're going to add only the power of 2 that has a 1 bit. So we have here 128 plus 16 plus 8 plus 4 plus 1. So we have here 157 base 10. So 1001101 base 2 is equal to 157 base 10. So in this example, we have here, or we have done the process in converting binary to decimal. Let's have another example. So we have here 110101110 base 2. So we're going to convert it into decimal. So again, we're going to write the place value or the power of twos. So we have 1, 2, 4, 8, 16, 32, 64, and 128. So since we have 8 bits, a set of 8 bits, so we're going to write the corresponding binary numbers. So we're going to write it on the bottom or below the place value or the power of 2. So we have to write below 0. So there's no need to write number 1. So since 1 is, or 2 power of 2 has a 1 bit, so you're going to write 2. So 4, because it has a 1 bit, 0. Then we have the 16, then 0, then 64, and then 128. So you're going to write, or to add, sorry, we're going to add all the numbers or the power of 2 that has a 1 bit. So we have 128 plus 64 plus 16 plus 4 and plus 2. So we have 214 base 10. So 11010110 base 2, we will have a decimal number equivalent of 214 base 10. So we have also another what do you call that? Another method in converting binary to decimal conversion. So we call it the doubling method. No, the doubling method. So how this method works, or how do we perform this method? So step 1, you're going to write down the binary number system or the number. So sample here is 10110001 base 2. And then starting from the left, double your previous total and add the current digit. So, so we have here, since we're going to start in computing or converting binary to decimal, there is no previous total. So if there is no previous total, so the previous total is 0. Then we're going to multiply it by 2 or double it and then plus 1. Now, so you're going to add the current digit, which is 1. Next, double your current total and add the next leftmost digit. So we are done with the 1. So we have now we are going to have the 0. So the previous total is 1, underlined by color blue. So we have 1. We're going to double the previous total. So 1 times 2 plus the current bit, which is 0. So plus 0. So it is equals to 2. Next, you're going to repeat the previous step. So repeat the step. And then we're going to have the previous total is 2, underlined by color blue. You're going to double 2, which is 2 times 2 is equals to 4. And then the current bit, which is 1. So 2 times 2 is 4 plus 1 is equals to 5. And then again, you're going to repeat the previous step again. So the previous total is 5. You're going to double the 5. So 5 times 2 is 10. And then the current bit is 1. So plus 1 is equals to 11. And then again, to the next step. So the previous total is 11. So 11 times 2, then plus the current bit, which is 0. So 11 times 2 is equals to 22. And then next, you're going to repeat again the previous step again until you finish or end the bit in the given binary number. So we have 22, the previous total. So you're going to double the 22, which is 22 times 2. We have 44 plus 0 is equals to 44. And then the last bit. So we have the previous total of 44, double the 44. You're going to 44 times 2 is 88. And then plus 1, we will have 89. So the final answer will be 89 base 10. So 10110001 base 2 is equals to 89 base 10. Okay? So let's have an example. So this example of this binary number is like the example in the previous method. So we have 1001101 base 2. So let us have this example so that we can compare the answer in this method to the previous method. So in the previous method, we have the answer of 157 base 10. So let us see. So we have 0, which is the previous total since we start doubling the total. So we have 0 times 2 plus 1, which is the first bit on the left side, and then we have 1. Next, we have the previous total, which is 1, then times 2 plus 0, which is the next bit on the left side, and then equals to 2. And then the next is 2, which is the previous total. times 2 plus 0 again, the third bit from the left, is equals to 4. Because 2 times 2 is 4 plus 0 is 4. Next, we have 4 times 2, which is 8, plus 1, we have 9. So 4 times 2 is 8 plus 1 is 9. So next, we have the 9 times 2, then again plus 1 is equals to 19. So 9 times 2 is 18, plus 1 is 19. And then we have 19 times 2, we have 38, plus 1, we have 39. And then again, we're going to double 39 times 2 plus 1. So we have here 78. Okay, 39 times 2 is equals to 78 plus 0 is 78. Okay, and then the last bit, 78 times 2 is 156. Then plus 1 is equals to 157. So 1001101 base 2 is equals to 157 base 10. As you can see, so whatever method you're going to use in converting binary to decimal, you will have an equal, or you will have equal answer or the same answer. Next, this is also this is also the same with an example in the previous method. So the answer in the previous method is 214. So let us have this method, doubling method. So 0 times 2 plus 1 is equals to 1. And then 1 times 2 plus 1 is equals to 3. Then 3 times 2 plus 0 is equals to 6. And then 6 times 2, 12, plus 1 is equals to 13. Then 13 times 2 plus 0, we have 26. And then 26 times 2 plus 1 will have 53. And then we have 53 times 2 plus 1, we will have 107. And then the last bit, 107 times 2 plus 0, we will have 214. So 11010110 base 2 is equals to 214 base 10. Okay, as you can see, we can have the same answer even though we use the previous method and the doubling method. So it's up to you what method are you going to use in converting binary to decimal. Okay, so those are the process in converting binary to decimal and decimal to binary. So if you have questions or comments in our video, so just write it on the comment box so that I can answer your queries about this topic. Okay, so these are our references. So you can check my data or my theory in this site of or this website. Okay, so thank you for listening and see you on my next video. Thank you and God bless.